Hi students, let us understand the concept of Choquet integral in detail. So we had some discussion in the session today and we discussed some examples. We will revisit those examples and understand how Choquet integral works. Before that, let us understand the concept. In simple terms, we can say it is a smart way of averaging data. Unlike simple arithmetic mean, where all the data points are treated equally, the Choquet integral takes into account how groups of data interact with each other and how important different combinations of data are, right? Why is this useful? Let us say we have a scenario where we are planning a team project. Now we have several team members. Let us say for simplicity, we have three team members A, B, and C. Now each of these team members will have different skill levels. How do we arrive at the overall skill level of the team? You might say we can arrive at the figure by taking a simple arithmetic mean. Let us say the skill level of A is S1, skill level of B is S2, skill level of C is S3. These are the three data points S1, S2, S3. We can say X1, X2, X3, whatever. Now in simple arithmetic mean, we simply add them and divide by the total number of workers or employees, in this case 3. But will this give us the average or the overall skill level of the team in true sense? Well, there can be a possibility that one of the team members might be more skilled than the other. And in that case, we need to assign weights which give that relative importance to the skill levels. That brings us to the concept of weighted arithmetic mean, which we discussed in today's session. And the formula modifies to W1 S1 plus W2 S2 plus W3 S3 upon 3. Now, we can order the values S1, S2, S3 from lowest to highest. That brings us to OWA or ordered weighted average. In another form like power mean, we also understood how we can form different weights to give different levels of importance. So there are two methods we discussed. One is arranging the data points from smallest to largest and accordingly assigning weights so that the higher data points or higher value data points get more preference. The other way is working with the formula of weights using some standard formula like power mean. The Choquet integral combines these two concepts. Now, in this concept, like in concept of trimmed mean or median, the ordering of the data points is important from the smallest to the largest. The second thing is assigning of weights is also important, and that is done by a concept called fuzzy measure, or in some scenarios it's also called as capacity. Now, the important thing here we need to understand is we are not only assigning weights to individual team members in this case or individual data points, we are also looking at different combinations of the data points. What do we mean is if we think that A and B can complement each other's skills, and because of that, if they are placed together in a team, they might increase the productivity to a higher degree. Or alternatively, let us say B and C don't want to work with each other. Somehow their temperaments don't match. And because of that, if they are placed together in a team, they may affect the productivity of the team. So what we are talking about is different subsets formed by the data points. And then we need to assign weights to these subsets also based on the relative importance. And all this can be done using the concept of the fuzzy measure. So what exactly is a fuzzy measure? We can think of it like a rule book that assigns a weight or importance to different subsets or groups of the data points based on how valuable they are when they are working together. Okay, let us say when A and B work together, they complement each other. So fuzzy measure might assign a higher importance to the subset comprising of A and B rather than to a subset comprising of B and C, wherein because they can't work together efficiently, the fuzzy measure value indicates their less importance. Now, there are certain rules when we try to give fuzzy measures. As you can see on the left side of the screen, first thing is a fuzzy measure allocates a value between 0 and 1, and these two extreme values are also included. Okay, we will see shortly through this example. Second rule is that the whole set or the whole group, in this case comprising of all the members A, B and C, the fuzzy measure for this set is to be assigned 1. The third rule is that of monotonicity. What it says, when you add new elements to a subset, the fuzzy measure should either remain same or increase. It can never decrease. That means, for example, fuzzy measure assigned to A must be less than or equal to fuzzy measure of a subset which contains one or more elements. Let us say A and B. So when you add one more element, it can never decrease the fuzzy measure value of the original subset. The third rule. Now, having discussed these basic concepts of Choquet integral, let's revisit the example 4.6 we discussed the class and work out the Choquet integral value. As you can see on the screen left side, example 4.6 says, suppose there are 3 workers and their output depending on the team is determined by the fuzzy measure shown previously. This was what we missed in the class discussion today. So what is this previously means that it is indicating these fuzzy measure values which are mentioned here. We need to take into consideration these values. For example, I think we mistook the values of fuzzy measures in the session to represent that of the data points. If you remember, we said, worker 1 by himself finishes or contributes 30% of his time for that project per day. So we gave that fuzzy measure for worker 1 as 0.3, whereas that was not the basis. It is already mentioned here. By that concept, we calculated or worked out the fuzzy measure of worker 3 as 0.4, whereas in the context of this example, it is 0.7. Fuzzy measure of second worker was, we mentioned it as 0.6, it is 0.3. So let's again calculate it. My apologies for the confusion in the class while explaining this concept. Let's again revisit this example and solve it. But before that, let's see what is the standard definition of Choquet integral, Choquet discrete integral. And as you can see on the left side, there are two formulae. One is this, what we discussed in the class in general, and the other is this, which is mentioned in the content of the course you have with you, right? So we will try to solve this question using each of these formulas separately, because both formulae are indicating the same output or same value. So that is out of the context of this book, that we can derive one formula and make it equal to the other formula. However, we will solve this example using these two formulae sequentially. Okay. All right. So as you can see, the inputs for solving the example 4.6 are shown above along with the formula. We will also solve this using the second formula, and hopefully it will give us the same answer. So let's see. Now we will start with first step, which is nothing but ordering of the input values in ascending order. So we have got the data set 0.3, 0.6, 0.4 for worker 1, worker 2, worker 3. Now when we order it, it will be in this form after ordering. This is the notation. So first one entry will be 0.3, and in ascending order, the second one will be 0.4, and the third one will be 0.6. Now we have to note here that this is the value of I. We need to consider when we are expanding the formula in the subsequent steps. However, we also need to understand that these particular values need not be the original x1, x2, this is the x3 work. But when we put it in the formula, we will put it based on the within parenthesis I, which is the sorted values. For that, the I value is to be multiplied by 3. Okay, that's the thing if you don't want to make mistakes. Now let us proceed to step number 2. And the step number 2 is simply expanding the formula. So we will start term by term. So first term, and what is the first term? For the first term, we have value of I is equal to 1, and therefore the first term x of 1 after rearrangement is nothing but 0.3, as you can see above. The fuzzy measure for the first expression of I to n is nothing but I is 1 in this case and n is 3. So I is 1 and then n is 3, and that means the subset 1 comma, see here the second element is the original third element, so I will write accordingly, and then the third element is the second element after rearrangement. So I hope you understood this. So it can be written as 1 2 3 because set can be in any order, but for avoiding confusion I am writing here, which will become more clear as we develop further terms. So this is obviously the universal set, so it will be 1. The ordering of the numbers doesn't make any difference here. Okay, now the second expression in the term, it is nothing but equal to fuzzy measure of I plus 1. Now what is I plus 1? I is 1, so I plus 1 is 2 to n. This first term was nothing but fuzzy measure of 1 to n. We developed this. Now it is minus fuzzy measure of 2 to n. So what is fuzzy measure of 2 to n? So element 2. Element 2 is our original element 3. So I will write 3. And element 3 is our original element 2. Again, to avoid confusion, I am writing it. So we can write it as 2, 3. But we are writing in specific sequence to avoid confusion. And fuzzy element of 2, 3 or 3, 2 is same. So it is 0.7. Okay. This is our first term. And when we expand this, it will become, first term will become 0.3, which is x1, multiplied by 1 minus 0.7, which is 0.3 into 0.3, which is 0.09. Now then we similarly expand the second term. Second term is I is equal to 2. Now x of 2 after rearranging is nothing but 0.4. Now the fuzzy measure here is from I to n. So originally we should write it as per the formula is fuzzy measure of 2 to n. So original, not original element after rearranging, what is the second element, that is this, to n, and which is nothing but fuzzy measure of second element is actually the third element. So again we will write 3, and the third element is the second element, so 3 comma 2, which is same as 2 comma 3 by the way. Okay, so here also I will rearrange the brackets, because this is the set notation and this is the function value. So now fuzzy measure of the subset containing elements 3 and 2 is nothing but 0.7. This is the first term. What is the second term? I plus 1. I plus 1 is fuzzy element of third term. Okay, and to the third term or n. Okay, so what is this? Now third term is our original second term, so we should not get confused here. So it is basically only the third term, third to n, because n is also 3. So the third term is our original second term. Okay, and that means we should write original value to here, and that is nothing but as per the above data it is 0.3. So hope this step is clear. So we need to understand the value of I is very important to be considered, and that I is nothing but after sorting the x values. It should never be confused with the original x values. Okay, in the session I think we got some confused about this particular understanding owing to the paucity of time. So it is very clear that the third term is our original second term is our original third term. Okay, accordingly this will be the expansion of second term, and when we expand it we will have second term as the value is 0.4 multiplied by first term is 0.7 and second term is 0.3. So 0.7 minus 0.3 is 0.4. It is nothing but 0.4 into 0.4, so 0.16. Hope it is clear. Proceeding similarly, we will develop the last term, which is the third term. Now for this third term, I is equal to 3. So x of 3 after rearranging was the original second term, which is 0.6. Now we have the first term I to n. I to n. In this case, I is third value. So third value. N is, you can write it as n only for now. So n. So this is equal to nothing but the third term is nothing but what we already developed. It is the original second term. So it will be fuzzy measure of second term, which is 0.3. And what is the second term? The third second expression in the third term is I plus 1. I plus 1 is 3 plus 1 is 4 to n. And there is no fourth element. So the fuzzy measure for this is 0. So the third term will expand to 0.6 multiplied by 0.3 minus 0, which is nothing but 0.6 into 0.3 is 0.18. So again, I will repeat. When I is equal to 1, x of 1 after rearranging was 0.3, and the two terms were subset 1, 2, 3 and subset 3, 2. Because the third set is the second after rearranging, and second set is the third, second data point is the third after rearranging. That is why I wrote in the sequence. Similarly, second term also can be developed and third term is developed. Now when we consider them together, the overall discrete Choquet integral becomes 0.09 plus 0.16 plus 0.18. 0.09 plus 0.16 plus 0.18, which is nothing but 0.09 plus 0.16 is 0.25 plus 0.18, which is nothing but 0.43. Okay, so in a different way it was solved in the book, but the answer we are getting using the standard formula of Choquet integral, which is 0.43. Now let us again revisit this using the second formula which was mentioned in the book, which is the formula shown here. Okay, let's see how it works out, and let's hope the same output or same answer we get. As you can see, the second formula now is displayed on the screen, and let us see how the terms are developed. So the first term is now I equal to 1. So it talks about x of I, that is x of 1. So x of 1 minus 1 after ordering, obviously, minus x of I minus 1 is x of 0. So what is this? This is nothing but x of 1 after rearranging is 0.3, and there is no term x of 0, so we can take it as 0. So it will be 0.3. So what is the weight? Weight is given as the fuzzy measure of the subset I to n, right? Now in this case I is 1, so it is nothing but a fuzzy measure of 1 to n. So basically 1, 2, 3, but as we discussed earlier, we can write it as again 1, 3, 2 to avoid confusion, because the second element after ordering is the original third element, right? It's nothing but same as 1, 2, 3, because the set can be written in any order, and it is basically talking of the universal set. So the first term overall will be now, first term will be xi minus xi minus 1, which is 0.3, multiplied by the weight, which is the fuzzy measure of subset I to n, which is nothing but 1. So it will be 0.3. Okay, got it? Now let us develop the second term. So what is the second term? In this case, I will be equal to 2. So as per the formula, let us revisit the formula. It is xi minus xi minus 1. So xi means here it will become x of 2 minus xi minus 1 is x of 1, correct? And now x of 2 after rearranging is zero point 0.4, so it is zero point 0.4, and x of 1 is zero point 0.3, so zero point 0.4 minus zero point 0.3, which is zero point 0.1. The second term talks about the fuzzy measure. As you can see in the formula, fuzzy measure of the subset I to n. So here it is, second term is fuzzy measure of the set I to n, and what is I in this case is 2. So 2 to n is 2 to 3, but as we discussed again, to avoid confusion, it will be, we can write it as second element now is a third, so 3 2, and it is nothing but, as you can see above, 2 3 or 3 2, fuzzy measure is 0 0.7. So the second term is nothing but now 0 0.1 multiplied by 0 0.7, which is 0 0.07. Okay, let us now build the third term. The third term is I equal to 3. Now xi, which is nothing but x3 minus xi minus 1, which is x2. So x3 after rearranging is the second original second worker, which is 0.6 and x2 is 0.4. So 0.6 minus zero point 0.4 is 0.2. And the second, the varying factor or the fuzzy measure is now I to n subset, and in this case I is 3. So fuzzy measure of 3. Now the 3 in our case was the original second worker, so we will write 2. It should be very carefully understood. Okay, we cannot make mistake here. Okay, now this is nothing but, if you see above, the fuzzy measure for second worker was mentioned as 0.3. Okay, so now the third term can be developed as 0.2 into zero point 0.3, which is nothing but 0.06. So the first term was 0.3, second term was 0.07, third term was 0.06. So we can write CV of x by combining these three terms and adding them. 0.3 plus 0.07 plus 0.06. Nothing but 0.3 plus 0.13, which is again 0.43. So we got the answer same using the second formula also. Hope you understood. The main points we need to consider are, first we need to alter the data points, and after altering, the I value is to be noted carefully. So in this case, the third worker has become the worker number 2 after sorting, and accordingly we have taken the relevant values as discussed earlier. Okay, so this is how, as one of you said, it is a way of solving Choquet integral using this example. Okay, let us now discuss the second example and the Choquet integral, how it works out in that, using both the formula again. Now this is the example number 4.4.5, and you can see on the left side of the screen the original example, and we have pasted relevant values on the screen along with the formula, which is the first version of the formula. Okay, so what does the question read is, suppose the student scores are given as below, and by the way, it is a problem of evaluating students for a scholarship based on their scores in mathematics, physics and English. And suppose the student scores are given as follows, whatever are indicated for Sachin, for Courtney and for Wasim. One thing we want to account for is that students who are good at maths are also often good at physics. So in combining their scores, We don't necessarily want to double count this ability, and we also want to importance of maths and physics to be higher than English. Okay, so there are certain considerations from the business perspective. Okay, so we noted that in the question it is mentioned there is no consistent weighted mean with the preferences which are required. Okay, now fuzzy measures are indicated here. Okay, so whatever is the requirement we read, based on that the fuzzy measures have been mentioned here, and we have entered the same on the screen. So now let's see how the Choquet integral works in this case. So again, for the first term or for Sachin, okay. So what is the first term? Sachin. So now Sachin's scores are 18, 16, and 10. Okay. Now this particular data set is pertaining to Sachin. So we need to order it in ascending order. So what is it in ascending order for Sachin is nothing but x is equal to 10, comma 16, comma 18. So original entry of English has come first now, I equal to 1. Okay. I will just write that also for our clarity. So this is I equal to 1. This is I equal to 2. This is I equal to 3. So for Sachin, we will calculate each term. So based on the same formula. So first term will be now x of 1. X of 1 is 10, right? So bracketly write 10 and multiplied by the fuzzy measure of the subset I to n. I to n is nothing but 1 to 3. Okay. In our case, it is nothing but 1 is 3, original 3. So this was our original x3. This was our original x2 and this was our original x1. But after rearranging, this became x1, this became x2, this became x3. Correct? So we will write the calculation below. So for Sachin, what is the first term? First term is x1, which is 10, multiplied by the fuzzy measure of the entire cell, whether we write it in any order. So the fuzzy measure we are talking about is of the universal set, in this case 1 to n or 1 to 3, so it will be 1. Okay, minus fuzzy measure of I plus 1, so second element to third element. Now second element is 16 in this case, third element is 18. Okay, so originally it was x2 and then x1. So, or we can say here, we already know it, 16 is physics and 18 is math. So what is the fuzzy measure of physics and maths? Physics and maths is mentioned as 0.5. So that is 0.5 here. Hope it is clear. So the first term will be 10 into 1 minus 0.5 is 0.5. 10 into 0.5 is nothing but 5. Now the second term for Sachin is x2, which is 16, multiplied by, now what is the fuzzy measure here? 2 to n. Now 2 is nothing but the element 16 and n is third, this is element 18 or original x1. So we are talking of 16 and 18, which is physics and maths. Okay, physics and maths is nothing but 0.5 minus I plus 1 is 3. 3 to n is nothing but 3 only, but the third element in this case after rearranging is 18, which is nothing but maths. And the fuzzy measure for maths is 0.45. Correct? So 0.5 minus 0.45 is 0.05 and 16 into 0.05 is nothing but 0.8. Now the third term for Sachin is x3. Now after rearranging, x3 is 18 and we have the formula says fuzzy measure of subset I to n, so 3 to n. So 3 to n is 3, but the third element is 18. So fuzzy measure of 18 is nothing but score in maths for Sachin. So fuzzy measure of maths is 0.545. Correct? And after that, the second formula says fuzzy measure of I plus 1. So 3 plus 1 is 4. So there is no fourth subject. So we can write 0. So 0.45 minus 0 is 0.45. 18 into 0.45. So what is 18 into 0.45? 18 5s are 90 and 18 4 is 72 plus 9, 81. So it is 8.10. Okay, so this is for searching. I hope it is clear. Now let us develop the same for the second student, which is Courtney. So for Courtney, as you can see, the subject scores are 10, 12, 18. So they are already in ascending order. So X is nothing but, in this case it is 10, 12 and 18, which is nothing but original X1, original X2, original X3 are the same here after rearranging. Okay, this is a easier case now. So let us again work out. So first term, which is nothing but 10 multiplied by fuzzy measure of 1 to 3, okay, which is nothing but the full set 1 minus fuzzy measure of 2 to 3, that is second element, third element. So 12 and 18. 12 is nothing but score in physics, 18 is English. So physics and English. Physics and English is nothing but 0.9. So we have 10 into 1 minus 0.9. 1 minus 0.9 is 0.1. 10 into 0.1 is 1. The second term similarly can be developed. X of 2 is nothing but 12 and subset 2 to n. So here it's the same thing, 12 and 18. So 12 and 18 are nothing but scores in physics and English. So physics and English, the fuzzy measure says it is 0.9 minus, what is this thing, 2 plus 1, the second term, 2 plus 1, so 3. So 3 to, again 3 only. So it is fuzzy measure of the third, that is, which is 18 in this case, which is English score. Fuzzy measure of English is 0.3. So this is 0.9 minus 0.3 is 0.6. 12 into 0.6 is 7.2. Correct? Now the third term. Third term is again easy to build. So it is 18 here multiplied by, so I to n, I is third, 3 to 3, which is nothing but the score of 18 is got in English for Courtney. So the fuzzy measure is 0.3 and I plus 1 is 4, so there is no 4 the subject, so 0. So 18 into 0.3, it is 5.4. So for Courtney, these are the three terms. Oh, we did not add it for Sachin. So Sachin, it will be 5 plus zero point 0.8 plus 8.1, correct? And for Courtney, it is 1 plus 7.2 plus 5.4. So what do these two sums yield? 5 plus 8.1 is 13.1, 13.1 plus 0.8, 13.9. And here 1 plus 7.2 plus 5.4. So 8.2 plus 5.4, 13.2, 13.6. Correct? Okay, let us proceed for the third student, Wasim, in a similar way. Now, what are the scores Wasim got? Let us scroll up. So 14, 15 and 15. So it is also arranged in a non-descending way. Okay. So 15 and 15 are same. They have been sorted after 14 already. So we have easy case here also. So we have 14, 15 and 15. This was the original x1, x2, x3, and after arranging also it is x1, x2, x3. The order has not changed. So the first term in this case is 14 multiplied by the fuzzy measure of I to n, which is the universal set, which is 1, minus fuzzy measure of 2 to n. In this case it is 15 and 15, and 15 and 15 he got in physics and English. So fuzzy measure of physics and English is 0.9. So 1 minus 0.9, which is nothing but 1 minus 0.9 is 0.1. 14 into 0.1 is 1.4. The second term similarly is nothing but 15 into fuzzy measure of 2 to n, 2 to n, second and third elements. Again 15 and 15, which is physics and English. So physics and English is 0.9. So it is 0.9 minus fuzzy measure of the third. Third is again English. So fuzzy measure of English is 0.3. So 0.9 minus 0.3 is 0.6. 15 into 0.6 is 9.0. And the term 3 can also be developed like this. So here the x3 will be 15 again, and subset will be 3 to 3, which is final one. That is, I think it is English, right? Yes, English. So fuzzy measure of English is zero point 0.3, and there is no fourth subject, so there is no fuzzy measure for that, it is 0. And zero point 0.3 minus 0 is 0.3, 15 into zero point 0.3 is 4.5. Correct? So now we will add up these three terms per passing, which is 1.4 plus 9.0 plus 4.5, which is nothing but 10.4 plus 4.5, 14.9. Correct? So these are the three uh, discrete Choquet integral values for the three students, right? These values are what are tallying as per the book also. So this formula has been able to give us the correct result. Now we will see the second formula and calculate the values as per the formula. Okay. So let's continue. We can rub off these things. All right. We will continue for Sachin. So that first term says it is uh, xi minus xi minus 1. So what is xi in this case? X1 after rearranging minus x0. There is no zero term, so x1. For Sachin, after rearrangement, we got 10, 16, 18. So x1 is nothing but after rearranging it is 10, and there is no x0, so 10 minus 0 is 10. Correct? Now, the fuzzy measure value. So it is fuzzy measure of set I to n. I to n is nothing but 1 to 3. So in this case, we can write the first term is now the original third term. So it doesn't make any difference, but we will write the order accordingly. Then followed by 2, followed by 1, right? So fuzzy measure of this is anyways 1. Okay, so the overall term will be now for this formula b of x is equal to 10 multiplied by 1, which is 10. Correct? Similarly, the second term for Sachin is nothing but x2 minus x1, and that is nothing but after rearranging the second one, x2 is 16 minus x1 is 10, which is nothing but 6. And the fuzzy value for this is I to n. So I to n is 2 to n, right? So 2 to n. What is the second element? Is the original second element, but n third element is the original first element. So 16 and 18. So what is 16 and 18? 16 is physics core, 18 is maths. So fuzzy measure of physics and maths. Physics and maths is zero point 0.5. So it is, I can directly write it as 0.5 here, a fuzzy measure. I will write it as 2 to n, right? And it is zero point 0.5. So 6 multiplied by zero point 0.5 is the second term. So I will not put equal to because this needs developing by adding the second term. So second term is 6 multiplied by 0 0.5. And the third term. Now what is the third term is? I will erase this second term calculation and let's see what is the third term. So third term is nothing but x3 minus x2. So x3 minus x2. After rearranging, the third one is 18 and second one is 16. So 18 minus 16, which is nothing but 2. And what is the fuzzy measure in this case? Fuzzy measure is that of I to n. So I is 3 here now for the third term. So I to n, I3 to 3 for the third one. Third one is nothing but 18 here. 18 is the score of math. So fuzzy measure of Okay, max, fuzzy measure of max is 0.45. So basically it is 2 into 0.45. So adding up all these three terms, the Choquet integral for Sachin works out to 10 plus 3 plus zero point 0.9 is 13.9. Okay, which is what we got in the previous case also, right? Let's continue with Courtney. So we draw above the original calculations. I'm using the previous formula. Now we have for Courtney, the formula says xi minus xi minus 1. So in this case, xi x1 minus x0. x1 is already the original x1, so x1 minus x0 is nothing but 10 minus 0. Directly now multiplied by the fuzzy measure of I to n. So 1 to 3 is nothing but here it is fuzzy measure will be 1. So the first term will be 10 minus 0, it is 10 into 1 is 10. Correct? Now second term. So second term is xi, x2 minus x1, x2 minus x1. So x to 12 minus x1 is 10. And what is the fuzzy measure here we need to consider? I to n, 2 to n. This is 2 to 3. So what is 2? 12 and 18. So 12 and 18 correspond to physics and English for Courtney. So physics and English, that fuzzy measure is 0.9. So it will be zero point 0.9. So 12 minus 2 is 10. Sorry, 12 minus 10 is 2 into zero point 0.9. 2 into zero point 0.9 is 1.8. Okay, and similarly the third term, xi minus xi minus 1. So x3 minus x2. So 18 minus 12. And multiplied by the fuzzy measure of I to n. That is the third element. Third element is nothing but 18. 18 is score of Courtney in English. So fuzzy measure is 0.3. So 18 minus 12 is 6. 6 into zero point 0.3 is 1.8. Now when we add these three terms, we will get the Choquet integral as 10 plus 1.8 plus 1.8. So 10 plus 3.6, which is 13.6. Same value as we got earlier. Okay, we will proceed to Wasim. Okay, let's erase the previous calculations. Now xi minus xi minus 1. So x1 minus x0. x1 is after rearranging it is 14. 14 minus 0. And initially it is the fuzzy measure of the entire set. Okay, I to n, so 1 to 3. So irrespective of the order, it will be 1. So 14 minus 0 into 1. 14 into 1 is 14. And the second term is xi minus xi minus 1. So xi in this case now x2, 14 minus xi minus 1, 14. First term multiplied by the fuzzy measure of 2 to n. So 2 to n is nothing but the second term after rearranging is 15 because there was no rearrangement required. Third term is also 15. So 15 he scored in physics and English, and the fuzzy measure for physics and English is zero point 0.9. So 15 minus 14 is 1. 1 into zero point 0.9 is zero point 0.9. The third term xi is 3. So x3. So again xi minus xi minus 1. So here in this case it is 15 minus 15. And fuzzy measure of the third one, which is 15. In this case it's not required, but let's see 15 English. So it will be zero point 0.3. Now we know that 15 minus 15 is 0, and anything multiplied by 0 is 0. So if you add up these three terms, it will be nothing but 14 plus 0 0.9 plus 0, which is 14.9. So the same value we got using the earlier formula. So this is how we can use both the formulae for calculating the Choquet integral, and we have seen how we could be able to get the answers in both the examples. Thank you.